Hello, everyone. Good morning, good afternoon, or good evening. The authors, distinguished session chair, and invited guests. Welcome to Technical Session 5E. I'm Sanskriti Khamkar, and I will be moderating this session today. On behalf of the Global Knowledge Research Foundation and GR Scholastic, it is my great pleasure to welcome you to the 11th International Conference on Information and Communication Technology for Sustainable Development. That is ICT4SD 2026. This edition of the conference is being held in a hybrid mode. The physical conference is being held today in Goa, while the virtual conference is being conducted via Zoom from 9th to 11th July 2026. I hope you enjoyed today's informative and engaging technical presentations. In this session, we have 10 paper presentations. Each presenter will be allotted 10 minutes for their presentation, followed by 2 minutes for Q&A. At the 9-minute mark, I will give a gentle reminder so that we can maintain the schedule. I request all participants to stay connected with us until the closing remarks. If you have any questions or require any assistance during the session, please feel free to send me a message during the chat. Now, before we begin, it is my pleasure to introduce the session chair for this session. This session is chaired by Dr. Akhilesh Ashok Tayare, who is an assistant professor in the Department of Computer Science and Engineering at the P.R. Pote Patil College of Engineering and Management in Amaravati, Maharashtra, India. With over 16 years of academic experience, he specializes in intelligent systems, core computation, and modern cloud technologies. Welcome, sir. Would you please have to share a few closing opening remarks with us?
Thank you, madam. Am I audible?
Yes, sir, you're audible.
Okay. Thank you. Thank you very much. Okay. Good afternoon, everyone. It is my pleasure to welcome you all to technical session of the 11th International Conference of Information and Communication Technology for Sustainable Development, that is ICT 4SD 2026. I am Dr. Akhilesh Tade, Assistant Professor in the Department of Computer Science and Engineering at PR Pote Patil College of Engineering and Management abroad. And I am honored to serve as a session chair for this technical session. First of all, I would like to express my sincere gratitude to the Global Knowledge Research Foundation, GR Scholastic, the organizing committee, and all the supporting partners for providing me with this opportunity to chair this prestigious international session. ICT4SD has established itself as an excellent global platform where researchers, academicians, industry professionals, and students come together to exchange innovative ideas, discuss emerging technologies, and explore research that contributes to sustainable development. The remarkable participation from more than 65 countries reflects the growing importance of interdisciplinary research and international collaboration. Today's session consists of 10 research paper presentation covering innovative ideas and recent advancement in information and communication technology. Each presenter will have a 10 minutes for the presentation, uh, followed by approximately 2 minutes for question and discussion. I encourage all presenters to keep within allotted time so that every participant gets an equal opportunity. I also encourage the audience to actively participate in the discussion, constructive questions, valuable suggestions, and healthy academic interactions. To all presenters, I extend my best wishes. Your research efforts are highly appreciated, and I hope the feedback and discussion during the session will further strengthen your work. With that, let us begin the technical session 5E. So may I know the invite our first presenter to kindly introduce themselves and begin their presentation. Thank you, madam.
Yes, sir. Thank you for your encouragement towards the participants. Our first presenter is Prachi Trivedi presenting their paper titled A Multi-Level Leadership Framework for AI-Driven E-Government, a comparative analysis of smart city initiatives.
Good morning, everyone. I'm just going to share my screen. It is saying that you cannot start screen share while the other participant is sharing. So you have to unshare your screen so that I can share.
Yes, I've done that. You can share your screen now.
Just a minute. Can you see the screen now?
Yes.
Okay, good morning, everyone. I am Dr. Prachit Trivedi, along with Dr. Ruhi Sethi and Samram Patnaik from Amity University, Dubai. Today, we are going to present paper on a multi-level leadership framework for AI-driven e-government, a comparative analysis of smart city initiatives. So the index for today is what we are going to discuss is introduction, background, objectives, research, literature review, methodology, comparative analysis. We'll talk about the leadership framework, key findings, recommendation, conclusion, and followed by Q&A. So what is this paper all about? As we all know that artificial intelligence has taken over the world. Everywhere you see, every field you see, every industry you see, be it education, be it hospitality, travel, tourism, retail, logistics, supply chain, healthcare, everywhere you see, you can see the use of artificial intelligence into the day-to-day operations, and not just at the day-to-day operations but at the implementation and also at the planning level. Similarly, when the government start using the technology and specifically the artificial intelligence or AI in their day-to-day operations, running the government at the policy framework level and also at the implementation institutional levels, how it can impact and change the experiences of the citizens and also the efficiency and effectiveness of the governments at the city levels. So, the smart cities are the ones where we can see the integration of the artificial intelligence, Internet of Things, and big data for the government efficiency. Obviously, there are certain challenges. The key challenges would be the leadership and the governments, how they can uh, reduce this resistance of technology adoption is one of the challenges that the government faces during the adoption of the technology in their governance. And there are many research papers that I have read. They are talking about the technology adoption in the government, but in this research paper we are going to look at the three different levels, like from the micro, meso, and macro levels, and how at these three different levels the government is integrating the AI and the technology is one of the research gaps that I could find. So, the research objectives of this research paper is to develop a multi level leadership framework for AI driven e government, analyze the leadership across the selected smart cities, compare the government models. Which is obviously I have used the secondary data for this, and identify the success factors and implementation challenges. So, as I told you, while reviewing the literature review, I found out that there are papers on the technology adoption or the e governance or AI governance, but none of the research papers have talked about the three different levels of the government all together in one research paper. So this research paper has integrated the multi-level framework in one research paper and has given you a perspective of how the governments are using the AI and the technology at all the three different levels and how they are doing it. So this is the gap that we found. And moving on to the methodology, this paper, I have used the qualitative comparative multi-case study design. So this is based on the secondary data. There are four cases that I have taken on the four smart cities, which is Dubai, Singapore, Tallinn, which is the capital of Estonia, and Barcelona, which is in Spain. So we have the data sources from UN reports, OECD reports, the policy documents and journals from the latest, which is from 2023 to 25. And we have done the analysis across the macro, meso, and micro level governments. So there are four cities selected, and what is the reason for selecting these four cities is Dubai, because it has a very strong centralized AI strategy and rapid implementation. As I come from this city, and I know that how strong implementation of technology and AI the government has in this city, be it from the traffic control, from the controlling and the crimes, and looking at the different levels of the different institutional levels. The Dubai has surpassed any other city in the world. Singapore, because it has integrated national AI governance. Thailand, because it is one of the first digital first governance and has implemented the ID ecosystem, so which is the digital ID ecosystem. So it is one of the first cities to do that. And Barcelona is because it is very citizen centric and it has the participatory government along with the technology and AI adoption. So that is why at the different levels, these four cities we have used in this comparative analysis. So now, what are the multi-level leadership framework? Multi-level leadership framework consists of the three levels. The at the top is the macro level, which we talk about the planning, where we do the strategic vision, where we plan the policies, where we make the rules and regulations. So this is at the top, is strategic level, where how we have integrated the AI in this. The second one is the meso level. Meso level is where we are talking about the implementation of the policies and implementation of the strategic vision that leaders have thought of, and on what basis they have designed that structure. So how we are going to implement that at the institutional level is the meso level. So if we talk about the institutional coordination and governance mechanism, so what kind of mechanism government has in order to implement all these plans and policies related to AI and technology, and how they are going to integrate it with their day-to-day operations. And at the micro level, we have the citizen-centric approach, how we are encouraging our citizens to use AI, to use the technology in the e-governance. So how we are basically enhancing the citizen trust and adoption of the e-governance for the citizens, and engagement of the citizens with the government using the technology and AI. So this framework emphasizes basically the all the interaction at the three different levels and the feedback across all the levels. Okay, so this is the three levels that consist the overall multi-level leadership framework. Now we talk about the three different levels in details, how at the different level the four cities are performing. So at the macro level, like I said, it is at the national level, city level leadership, where the governments have created the policies, they have planned the policies, they have made the regulation for the successful AI driven digital transformation. So when we talk about Dubai, Dubai has the AI strategy 2031 in place, and it has a very centralized leadership. So because of this very strong centralized leadership, the directives are very clear. At all the government entities, they work towards this common goal of AI strategy 2031, and they try their best to achieve this goal while starting from as soon as the policy was implemented. So it has a very strong centralized leadership, and so why the directives are clear and the implementation of this becomes very strong in this case. Singapore has a whole of government policy coherence. So that means all the different ministries, the different portfolios, the agencies of the government, they collaborate with each other, they share their data with each other, and they implement all these AI policies across all the public sectors consistently. So that is why the approach is whole of government approach. So that whole of government at the national level is being coordinated and is being a part of the planning and also the implementation. Now, Talent is because it has a very long term digital transformation commitment. So, it has invested in the digital government for many years now. And the leadership also mainly emphasizes on the continuous innovation at the digital infrastructure and secure e government services. And Barcelona, because it has a very strong ethical AI policy in place. So all the transparency, the privacy of the data privacy of the citizens, fairness in all the transactions that is happening over the technology or the AI, and also the participations of the citizens at the different levels has been ensured that it should happen at all the three different levels. So at the macro level, these are the four cities that are very strong in how they are doing it. At the meso level, where we talk about the institutional coordination and how the implementation of that policies and plans that has already been designed by the government. So at the meso level, the Dubai has, like I said, it has a centralized leadership. And so why the directives are very clear and very direct towards the implementation of any policy. So the government agencies receive clear directions on how to implement that particular policy, at what level to implement, where to implement, and how to implement it. So it enables a very faster decision making, and it has a consistent implementation of the AI initiatives. Talking about Singapore, it has a collaborative cross-ministry coordination, like we discussed at the macro level, because it has a whole of government approach. Similarly, all the government different institutions and ministries that at the implementation level, they collaborate with each other and they implement those policies and plans all together as a whole. Now, Talent has a very adaptive, decentralized structure, uh, just the opposite of Dubai. Dubai has a very mm, a centralized structure. Talent has a very decentralized structure. It empowers individual government agencies to innovate their own way of how they are going to implement those plans and policies that has been made by the government. So it makes the system very flexible, and it improves the improvements comes at the institutional level as well. Now, Barcelona has involves the citizens in the decision making, because it has this citizen centric approach, and whatever the AI policies they are implementing, they make sure that the feedback comes from the citizens as well. So at the meso level, this is how all these four cities are performing. Now at the micro level, which focuses on the citizens, the ultimate end users of AI enabled public services. So this at the micro level, we have to make sure that the citizens are engaging with the services, government services using AI and technology, shows their trust, builds their trust, adopt those services, and that is how ultimately the success of the whole system depends on. Unless and until the citizens are actually involved and engage with these services, there's no use of creating anything and everything. So that is why when we talk about in this, so Tallinn is the one which has the very first city which has used the digital identity, and that starts to build trust in the citizens. Singapore has a very seamless integrated digital services. So they have one particular system where all the different services can be accessed, the multiple government services can be accessed through a single system. Dubai has very smart service adoption. uh, all the different government services here, whatever we use, we can just go to any of their websites, and we can complete the whole service without even visiting the government offices. And Barcelona has a participatory digital platform, so it encourages the citizens to actively participate in the governance through the digital platforms, and where they can provide their feedbacks, where they can contribute to the public decision making. So like we discussed, like Barcelona is very citizen centric. So and from the starting of the macro level to meso level to micro level, they have made sure that citizens are a very strong part of this whole framework. Now, there are certain key findings. So, after looking at all these three different levels of the government AI adoption, there are key findings that strong policy leadership accelerates AI adoption.
Excuse
So
me.
unless and until, yeah.
Sorry to interrupt you. This is just a gentle reminder that 1 minute is left for your presentation, so please conclude.
Okay, yeah, sure. So we have to make sure that leadership is very strong in order to make the AI adoption. Institutional coordination is required so that whatever the policies are made should be implemented successfully, and citizens' trust is required because why not? These are the ultimate users of the services that whatever the planning and implementation has been done by the government. So comparative analysis, if we look at policy leadership, Singapore is one of the cities which is accelerating in that. At the implementation leadership, Dubai is the one which is highly implementing everything at a very fast pace. Digital infrastructure, Thailand has the great digital infrastructure because they have been investing in this for a very long time now. And Barcelona is obviously the citizen engagement. They have accessed the list in that. There are certain challenges of it, obviously the ethical concerns because of the bias, transparency, accountability. These are the certain challenges that are being faced by the governments while adopting the AI and technology at the different levels. Data privacy and cybersecurity risk, this is a factor which is one of the most challenging factors, that how you are going to save yourself from the data privacy leaks and the cybersecurity threats that we get every day. Institutional resistance to digital transformation, how the institutions resist in adopting the digital transformation, and fragmented government and interoperability issues. The limitations of this research paper is because it depends on the secondary data. So there must be some primary data, and the quantitative data can be collected in order to get the more focused results on the particular topic. So the conclusion says that AI-driven governments requires leadership across all governments levels. There should be policy coherence, institutional coordination, and obviously the citizen engagement are critical factors in the success of AI adoption in the government. And the framework bridges obviously the digital theory, leadership theory with digital governments. And the obviously, like I said, the limitation of this research paper is that it is only based on the secondary data. We can have more empirical and qualitative validation by doing the primary data. Thank you so much. Any questions?
Good, Prachin. Uh, my question is that what is the role of AI in traffic management?
In traffic management? Yeah, so this is in like I live here in Dubai. This is one of the, sir, I can tell you how strong they are in doing the traffic control and traffic management with the help of AI. So for example, if you are going on the road and if you access the track limits or the the speed limits, they have cameras at every 1 kilometer. At every 1 kilometer, if your the speed exceeds, you will get a fine for that. At every traffic signal, they have the cameras installed, and if you cross the red light, they will fine you for that. Not just that, now they have AI integration in the cameras that can look you if you're eating something while driving, if you're reading something, if you're using the mobile phone, if you're not using the seat belt, and even if a child is sitting in the front seat, because the it is not allowed to have a child in the front seat. They has to sit at the back. Now even if you have that, you will get a fine for that. So now recently they have started, they have the cameras at the parking lots. So just at where you have the footpath, they have installed the cameras over there. So if you have, for example, parked for 1 hour over there, so you have to pay for 1 hour, and it is all digital. In the app, you can just go and park for pay for 1 hour. Now if that exceeds 1 hour, immediately after 10 minutes you will get a fine for that. So they have such a strong traffic control and traffic management system with the help of AI and technology, that each one of us is not worried where we are going, but we are worried where we are going to park the car.
Okay, what is the difference between micro internship and meso internship? Micro and meso internship.
So
Mentorship.
meso is basically the implementation level. That how you're going to implement these policies and whatever the frameworks and regulations has been planned and designed by the government. Micro level is where you reach to the citizens. At the meso level, you are not in touch with the citizens, but at the micro level, you get in touch with the citizens, you involve them into the adoption of AI. So that is the difference between meso and micro.
Okay, you have concentrated on the four cities, right? Which
Yeah.
cities having very good policies of AI out of these four?
You might feel say that I'm biased, but because I have seen the very first-hand experience of Dubai, so I would say Dubai. Because yeah, whatever I have read, I can see, I can say that the Thailand is good in this, Barcelona is good in this, or Singapore is good in this. But the first-hand experience that I have with is with Dubai. So obviously, I will go with Dubai.
Okay, thank you, Dr. Prachi.
Thank you so much, Dr. Akhilesh. Thank you.
Next one.
Thank you for your presentation, Prachi. Next, we have Rishabh Kirat presenting the paper titled A Multi-Vector Cyber Defense System for Threat Detection with Inbuilt Post-Quantum Secure Backend Communication.
A very good morning to the respected sir and everyone present over here.
Good morning, Rishabh. You may please start your presentation.
Is my screen visible, ma'am?
Yes, it's visible.
I am Rishabh Kirat and I am presenting my project, a multi-vector cyber defense system for threat detection with inbuilt post-quantum secure hacking communication. This project is being successfully made with the help of Samyak Dhongade and Riddhi City under the guidance of Manju Pawar. So this is going to be our flow of the today's presentation. Introduction, problem statement, objective, literature survey, followed by methodology, architecture, and then we will also go through the demonstration of the project, and then we will see the results, tools and technology used, and the screenshots and the future scope, and we will conclude the presentation. So in a model, in modern systems, the company face many challenges like phishing attacks, anomaly detection, insider threats. Also, now the quantum computers are going to come in future, where quantum computers are going to tackle the keys which we use for cryptography and securing our encrypted messages. So we have used post-quantum cryptography to secure the logging complications. So the problem statements is majorly there are four problem statements which we tackle. Existing system only detect a single category as a cyber threat, whereas for the long term it can be also be detected. Static models are being used to detect these attacks and user behaviors for the insider threat. In insider threat, the user behavior is being used, how the user is going to uh, control the system, how is accessing the system is being monitored, and the models are used to predict the systems. The traditional cryptography algorithm is vulnerable against the quantum attacks. So also when we use AI, we know that there are many false positives in AI predictions. So to tackle that systems, uh, the false positive rate, we have deployed several models with additional to our main model. So our objective, these are the seven objectives which we have uh, done. Firstly, the network anomaly detection is being using ensemble deep learning models. And insider trade, we have used graph-based behavior analysis. Phishing email is been uh, phishing email is using text URL and attachment analysis, attachment detection models. And that also in insider trade, we have implemented the drift detection, in which the behavior of the user is changed. In company, we have both, and the rules changes as per the requirement of the team. So the existing system fails to detect the new insider threats. So we have implemented the drift, plus the secure backend communication with the crystal fiber post-quantum cryptography, provided dedicated dashboard for easy analysis and display the attacks, which has been useful for the team to analysis which user is attacking or not. Improve the detection accuracy. We have reduced the false alarm, that's false positive rate, and deploy scalable and modable uh, cybersecurity framework. So the in literature survey, these are the four main papers which we have followed for the people for making this project successful. For the first project, uh, uh, LSTM model is being used. In LSTM model, it was been seen that the false positive rate was more, and no zero-day attack was secure by this model. Second, it was graph session uh, use system. In that, the same technology was the failure. Like if the role is being changed, the user is changed, uh, the accuracy falls. In this, we have changed the database and tested that system with it achieved the accuracy only of 0.47, whereas our system goes to goes and detect those insiders with accuracy of 0.88.87. In phishing detection, we have used multiple models to detect each part of the mail is being secure and how confident the user is. And in Pixel Driver, this paper has been published by NIST, and we have just followed their system for the secure communication. So the methodology we have uh, firstly the post-quantum cryptography for login system authentication layer. Input sources for our models are uh, the traffic network, user activity log, and email data. These are the three models: network anomaly detection, insider threat detection, phishing detection. Also, we have conducted threat alerts and visualizations on the dashboards. So in AI, to deploy this AI system, we have built these models. For anomaly detection, we have bidirectional LSTM, which focuses on the current system, the current URLs which is being used for the attack. Transformers are used for the long-term purpose of long that this attack can affect the system. Convolution neural network is being used to detect the local vulnerabilities of the systems, whereas the last model is being used for the zero-day attack. This model is only trained on the normal URLs and the attacks which has been there. If it sees any vulnerable attack other than this, it will detect as an threat. In insider threat, we have used isolation forest and graph convolution network. Isolation forest has been used for the new users, and the new employees are going to join or change their role. In phishing detection, EFIDF has been used for the tokenization purpose of the text, and random forest is used for the classification of the models. This is the architecture. First, user is going to log in with his passwords and user credentials, which has been secured by the post-quantum cryptography. Then the uh, three models has been accessible for the user. The user sends network traffic, user activity, and email traffic. From this, the model feature selection has been done, processing has been done, and the prediction has been uh, given to the ensemble score, anomaly score, and phishing scores. From these scores is being used for the dashboards to detect and show the results. So moving Further, for the evaluation and results, I will like to share the demonstration of our project. This is how our interface look like. These are the three models, and here the login system is there. So you can access the three models. This is the first one, anomaly detection. I will demonstrate an attack on this system.
Excuse me, Rishabh. And this is just a gentle reminder that 1 minute is left for your presentation, so please conclude.
As you can see, the user's IP address and the attack they have been made. You can click on the IP address for the detailed uh, analysis of the system. Also, for the email, we have used mail transfer agent to get its real-time application, where you can see the mails and what phishing mails are being there, safe mails are there. It is a real-time system. The mails are being fetched from the emails, and it's being displayed that it's safe or not. You can view the mails from our systems, at which mails are being secure or not. Like the mail is being here, it's been displayed as a safe mails. If we go and check for the phishing mails, like I have one mail coming from Riddhi Sathe, the domain name is good, it's been valid, but the URL which has been used is not valid. So it's been detected as a phishing. Also, the insider threat which we have developed. So the diff detection makes this model very useful in real time. Since when we are going to predict on the trained data set, the model knows the functions and the which role is been assigned for the employees. Till then, the result is been displayed for the insider thread. We will look for the results that we have achieved. For most of the systems, we have achieved the accuracy more than 95%. Also, the false positive rate is being reduced in this all the models. Also, the phishing detection, the time taken for the detection is also less. This is the performance graph of our system. This is the graph for the isolation forest and graph session network. For the train system, the model gives accuracy of 97%, whereas isolation forest also gives us the accuracy of 97%. Whereas the base paper fails against the new users with the accuracy of 48%. These are the tools and the technology we have used. We have used front-end technology with the HTML5 JavaScript Bootstrap. Also, for CSS styling is being used. Backend, we have used fast data and Flux. For database configuration, we have used SQLite and MySQL. SQLite is being used for anomaly detection, where the system works fastly. Also, many machine learning languages is being used. Future scope will be a dedicated database is being needed for the insider trade. Also, a huge data set is being required for all the three systems. That can be done in future with implementation in cloud systems. Also, an explainable AI can be deployed on the system so that the non-tech user can also understand what type of attack is being done. Also, we are just used on the quantum security of Mr. Prival. We can use Mr. Beryllium so for the digital signature. And yes, that will make the system fully real-time deployment ready. In conclusion, mainly what we target for our objectives has been achieved for the getting the low false positive rate, getting a good dashboard, achieving of good accuracy for the models, making the models good for the real-time applications. So these are the objectives which we tried and got successful in it. Also, we implemented successfully the post-quantum cryptography using crystal fiber. So let's just see the insider threat predictions.
Okay, sir. My question is that what is email spoofing? Email spoofing.
So in email scooping, we have seen from getting mails. In this system, we have only used the Gmail account. We have not used my Microsoft Teams or which has been used in companies nowadays more rather than Gmails. For getting that Gmails from our system, we have used the MPA to get that email correctly on fetch the email directly from the Gmail.
What is phishing?
So phishing means attack can be done to get the credentials of the users or access the system or to send some virus through links or any attachment in PDF or images can be done on email so that the system get corrupted or get accessible to the unauthorized users.
Okay, what is malware in email?
In email, we can say if a link is going to direct you somewhere where you don't know. Whereas if you know that the link contains youtube.com, in such a link is printed, you know that it's going to direct us to the YouTube platform. Whereas there are some platforms which use indirect emails. Also, indirect URI is also been sent to the users, where users click but don't know where it's going to direct us. For example, the bit.ly is an example for the thing can be used for the phishing as a malware links. Also, in attachment, when we have seen nowadays that in WhatsApp also some images are being sent to the users where some virus has been attached in the uh, image backend system and the header for font is being sent. So same technique can be used in email also while sending the attachment of PDF and images.
Okay, Rishabh. Okay, thank you.
Thank you, sir.
Thank you for your presentation. Now we have Jaya Saxena presenting the paper titled An AI-driven scientific interpretation framework for multispectral and hyperspectral remote sensing data.
Respected session chair, the management, and my co-presenters, namaste and good afternoon, everybody. I'm Jaya Saxena, and we have done this work with the help of two interns, Jeevan and Saina, at National Remote Sensing Center, ISRO, Hyderabad. Just to give a brief overview of why we have selected this problem statement as we know, geospatial technologies, the space sector, remote sensing data, they are at the core of all the applications of the society, starting from communications to navigation to Earth observation. We are using this geospatial technology in all the domains, in all the sectors of the societal applications. And with the advent of new technologies like artificial intelligence, deep learning models, we are now trying to amalgamate these newer technologies, high compute, and huge petabyte order of data sets with the remote sensing to see that how we can enhance the utility and the applicability of remote sensing data with these upcoming technologies. So in this project work, we have tried to use deep learning based models for hyperspectral, multispectral remote sensing data to enhance their interpretation, classification, segmentation, and overall their applicability to the society. We have used this technology for land use land cover classification, and now my interns Jeevan and Sana will be presenting this work to you. Thanks at the outset. Thanks for giving us this opportunity to share our work with everybody. Yeah, please.
So coming to
Is our slide visible to all?
Yes.
So
Yes,
coming
sir.
to the introduction problem statement. So the evolution of remote sensing. So the remote sensing has evolved from traditional Earth observation into scientific intelligence. So the automated mapping of complex physical properties across the electromagnetic spectrum. However, there are some limitations in current methods, like current deep learning methods face two core limitations. First, computational bottleneck, like high-dimensional data layers introduce several computational overload and spectral and edge degradation. Traditional techniques cause edge blurring and blurring at complex urban and forestry boundaries. So our objective is to build a bifurcated dual pipeline architecture with balanced speed, processing speed, and with spectral depth designed for low latency web GIS platform. So coming to the literature review, so CNNs have proved highly effective at modeling nonlinear spatial spectral relationship, but scalability remains an issue. So the algorithmic trade-off. Computationally lead models like EfficientNet, BNOT, and hybrid CNNs often lack the spectral breadth needed to resolve complex class mixing. High fidelity spatial spectral models are computationally prohibitive for real world public deployment. So our contribution is we have to build a framework, an end-to-end framework that runtime bridges this gap by decoupling the hyperspectral processing into parallel domain optimized workflows. So coming to the methodology, we have implemented a dual pipeline architecture where the pipeline one consists of multispectral data which utilizes EfficientNet BNOT for low latency web deployment, and for pipeline 2 we have used hyperspectral data which uses hybrid CNN, where first it will be trained on unsupervised learning and then it will be trained on supervised learning, which can handle hundreds of contiguous bands without gradient degradation. And our key evaluation parameters are for overall accuracy, we have used to calculate the statistical ratio of correct cells across all classes, and kappa coefficient for thematic consistency versus ground truth, and inference time for time taken for classification accordingly. And coming to the mathematical foundation and optimization, to avoid or to mitigate the gradient degeneration, we use this standard residual mapping mechanism where y equal to f of x comma wi plus x, where x is the input vector and y is the output vector, and f is the learned residual mapping. For multispectral optimization, we have used leaky ReLU and dynamic atom learning rate optimizer to optimize the resolution and to also resolve the spectral mixing. And for hyperspectral optimization, the hybrid CNN combines 2D and 3D convolutions to simultaneously capture spatial and spectral features. It features target weighted initializations, Xavier for 2D and normal for batch normalization to stabilize high dimensional spaces.
So we have used these datasets. We have used Uresat for multispectral data, and for hyperspectral we have used Hyperion EO1. And the curation metrics are over 500 spatial samples for multispectral training. And for hyperspectral, there are 150 data cubes. And the pre-processing pipeline is it is a native 12-bit radiometric image data dynamically converted to standard 8-bit scales. In spatial normalization into 512 into 512 pixel arrays using GDAL built VRT function to ensure smooth spatial continuity. In minimum noise fraction transformation separate to eliminate hyperspectral sensor artifacts.
Coming to training protocol and implementation, we have used NVIDIA GPU accelerated high performance computing to manage dense matrix operations, and we also used early stopping mechanism to prevent overfitting. And this pipeline we have achieved in just 75 epochs, outperforming the standard 200 epoch baseline. And this pipeline also generates an automated attention heat maps, which will help us in visually tracking the light bands like near infrared for vegetation and also forest, etc. These are the training samples. The figure 1 shows the multispectral input sample, and figure 2 shows the hyperspectral input sample. And the outputs are output for these images are shown here. This is the bar graph showing the land cover percentage of the classes present in this image, and this is the land cover distribution of hyperspectral data of Mumbai, and here it shows the percentage of classes using the hybrid CNN model. Coming to the experimental results and model performance, our efficient net B0 for multispectral pipeline got an overall accuracy of 91% and kappa coefficient of 87. Key takeaway is rapid convergence, which we have achieved in 50 epochs with an validation accuracy of 92%. And we also used it for public web deployment. And coming to hybrid CNN hyperspectral pipeline, we got an overall accuracy of 94% and the kappa coefficient of 0.92, which also the key takeaway from this pipeline is it also mitigates the curse of dimensionality to capture high complex spatial spectral features. Coming to the framework, robustness and operational insights. So managing high spectral complexity in challenging terrains like Meghalaya, the hybrid CNN successfully distinguished between virtually identical spectral signatures such as dense forest and pasture shadows. So sensor and atmospheric sensitivity analysis. DQ-ReLU components maintained solid gradient flow during minor atmospheric scattering. Heavy aerosol optical depth or a drop in resolution 30 meter to 60 meter per pixel resulted in localized boundary degradation, highlighting the need for strict radiometric calibration.
Sir, like we know now, satellite data is very much useful for all the domains. So we are now shifting towards hyperspectral data, where we have multiple bands. Within one band, we have thousands of bands. So to get the finer details or the minute details about the agriculture or land use and cover or forestry or even urban developments, with using this hyperspectral complexity, it is we have used challenging terrains as told by the student intern Jeevan and China. Like we have taken northeast regions to have different type of topographical studies, and we have used hybrid CNN there to find out how much minute details we can go with this high spectral data, and also to find out where the spectral signals are very much similar. There also the model is able to identify different type of land classes present, and that's what we have shown in the previous results also, where they have taken Bangalore and Mumbai, that what are the different type of land features present. They were able to distinguish them with the model and very accurately. Also, the study also encompasses a time series data, which shows that over a period of time, how the city has grown or how the changes have taken place in land use and or urban development. So that shows us a time series data for different type of statistical studies. They're also using the VDAR library of Python, the edge blurring or the contrast diminution, all these errors also could be corrected using those things. That's what they wanted to show here. And then they've taken some data of Telangana. Yes, madam.
Sorry to interrupt you. This is just a gentle reminder that 1 minute is left for your presentation, so please
Yes.
conclude.
Thank you, madam. We'll be completing. So, and they also, sir, they have used different type of models. Like, and then finally we have come to the mobile. We have used mobile light and the other architectures. Then finally we have zeroed down to efficient net and had CNN for hyperspectral, and different type of activation functions also they have used. And finally, this is the study from which they were presenting.
So, concluding this, we have engineered and dual pipeline scientific intelligence framework for using efficient net B0 and hybrid CNN models. Efficient net B0 is used for multispectral data and hybrid CNN for hyperspectral data. So, in future work, we can integrate transformer-based vision backbones for complement existing CNN feature extractors, and also we can expand to multi-temporal datasets across diverse global climatic zones, and also we can incorporate real-time satellite telemetry pipelines into our open source web applications.
Also, since hyperspectral we are just now entering, we don't have much data available. We have used open source datasets and open source libraries. Now with the new space policy also, course resolution of 5 meter is available to all. So we have used all open source datasets so that everybody can do this type of study. If the future scope is, if we have more data in hyperspectral, our models can even be fine-tuned better, and with integrating with newer models like transfer-based vision backbones, etc., vision transformers, what is coming now, which is the research is going on for those things. If we integrate those architectures, we can even improve our study. So this was what we have done this thing, and already it is in the implementation stage. We are using for this student projects and for other studies. Further, we are using this type of classification for hyperspectral, multispectral, and we are further improving this also. Thank you very much for the opportunity. We are open to questions now.
Good afternoon, madam.
So good afternoon.
My question is how the hybrid CNN improve the accuracy?
Yes, sir.
Hybrid CNN, how it is useful for improving the accuracy?
So we have used this hybrid CNN, where in first we have trained these hyperspectral data cubes using unsupervised learning, and then we have trained it on supervised. After this unsupervised learning, these outputs are trained on supervised learning. Our outputs are converted into a data set, and these are trained on supervised learning model, which can, so the accuracy can be increased in that supervised learning.
Sir, using the multiplication factor of CNN, we are using with the convolution layer, then the pooling layer, and the activation functions in the final layer. We have used this thing 4 times so that we are using output of one as well as input of the next layer, the entire block. And then we have used 4 such blocks so that final layer we are using, when we are sharpening them, we are getting much more accuracy.
Okay. What is the use of kappa coefficient in your concept, in your topic?
So it is used to measure the efficiency of our model, sir. So we are testing this hyperspectral model, hyperspectral pipeline across different thematic areas, deep sea and also dense forest. So to avoid the confusion between dense forest and the forest, we are using kappa coefficient to compare the accuracy between how our model is correctly evaluating the dense forest and the deep sea and sea. So to evaluate the accuracy, we are using this kappa coefficient.
So as an evaluation matrix, we used to find out our derived results with the ground truth, how we are validating those things.
Okay. Can you tell me about something CNN? Something about the CNN?
Convolution neural networks?
Yes, convolution neural network.
Yes. Sir,
So we use CNN for mainly hyperspectral data, and where it takes the image and according to the bands, it classifies into 5 different classes. We used k-means, and after classification, according to bands, and it will again go to next layer by which color may be will classified into water, or which color will be under forest. In this way, it classifies using CNN and K-means.
So basically, CNN, we have to just to compliment them. Maybe they are feeling a bit nervous. CNN is a type of neural network which is basically used for the analysis of images. It contains a convolution layer which have different to find out different dimensions. Starts with the lower dimensions, and then we have a pooling layer which will reduce the dimensionality so that multi dimensions are which are there in the images can be lowered down to the important dimensions, and then we have the activation functions, which adds a non-linearity into this model so that we can have different basically CNN. If you don't have activation function, it's a linear model, just like a sequential linear model. So to have the non-linearity to capture the complex details or dimensions present in the images, we have the activation layer, and then finally we have the final layer which will convert all this pooling and activation products or outputs into a multiplier of these images and flatten the image to get at the output. And we have this different type of leaky READU as activation functions, and sigmoid we have used as the final layer for the classification.
Okay, thank you, madam.
Yes, thank you.
Thank you for your presentation, Jaya. Up next, we have Nutan Bansore presenting the paper titled An Integrated TI-RAD and CONNUS-based Framework for Automated Thyroid Nodule Classification Using Ultrasound Imaging.
Hello. My screen is visible? My screen is visible?
No, it's not visible.
No, my screen is visible.
Yes.
Okay. Good afternoon, respected session chair, distinguished delegates. I am Nutan Vasant Bansode from COP Technology University, Pune. Today, I will present our work titled An Integrated Thyroids and Conveys-Based Framework for Automated Thyroid Nodule Classification Using Ultrasound Imaging.
Hello.
The thyroid, yes,
Madam,
hello.
Please turn on your camera.
Okay. एक मिनट. Is it fine, sir?
Yes.
Okay. So, thyroid is a butterfly-like structure located on the front side of the neck. It secretes two important hormones, that is T3 and T4, and that T3 and T4 which controls the metabolism, body temperature, energy, productivity, as well as the growth of the human body. Here, if that thyroid is untreated, it may lead the serious complication for pregnancy as well as growth of the body. As the thyroid controls whole body, it controls the brain, it controls the nervous system, it controls the respiratory system. So our today's work focuses on the integrated thyroids and conveys based framework, so that this system can easily diagnose the thyroid nodule using the ultrasound imaging. This is the flow of my presentation. Now, to detect the thyroid in In market, there are different modalities are available like MRI, CT scan, blood test, which is a traditional method. These to detect to diagnostic the thyroid nodule. Different techniques are available like invasive technique and non-invasive technique. Thyroid ultrasonography is one of the non-invasive and radiation-free and cost-effective techniques. So this technique is used for our research work. The thyroid nodules are commonly endocrine abnormalities, and here to detect, basically the radiologist use this system, that is thyroid imaging reporting and data system, that was evaluated to diagnose the what are the exact point of that thyroid. With the help of these thyroids, there are total five features are there, five criterias are there, TR1 to TR5. So radiologists experts, after diagnosing the thyroid image, they can easily evaluate whether that cyst is a benign or a malignant category. Now here, different deep learning approaches are available in the market to detect the thyroid. However, many existing deep learning models are computationally complex, but they cannot they cannot integrate the clinically interpretable frameworks such as the thyroids. Now here our goal is to combine or to integrate the deep learning image feature with a structured clinical knowledge for accurate, interpretable and real-time diagnostic. Now why only ultrasonography? Because ultrasound images, why I'm choosing ultrasound images? Because ultrasound images are a non-invasive technique, non-invasive, radiation free and cost effective imaging, and it gives, wait a minute, it gives a clinically risk scoring with the help of a thyroid. And also we can early detect the patient, early detect the nodule, so that biopsy can be avoided. Now here, basically most of the existing methods generally combines the clinical and imaging information using simple feature concatenation. However, these techniques are only use the clinical guidance. They cannot use the clinical guidance such as a thyroid evaluation. They can use only the feature uh, f- uh, f- f- feature uh, feature information using the deep learning, so that it can reduce the interpretability. So many approaches are computationally expensive, limiting suitability for a real-time clinical development. Okay, to overcome all these lacuna, here in our system we incorporate the thyroid score as a structured prior knowledge to guide deep feature learning via an action based modulation mechanism, resulting in a more accurate, interpretable and computationally efficient model for a real time clinical use. Now, before starting our research, I have gone through the many articles, many research articles. From that article, came to know that the early studies focus on the deep learning CAD techniques for automated detection. In first four articles, I have observed this study. In the next, that is 5 to 12 articles, I have observed the approaches are focused on ensemble learning and machine learning. And in next articles, I have come to know that the recent work introduced the multimodal, transform based and hybrid deep learning models with automated segmentation classification pipeline. So this is the methodology of my system. So here there are this flow partition this flow categorized in a three section. One is the input section, second one is the pre-processing, and then feature extraction, and then that feature extractions are again computed with the help of thyroid system. And these two thyroids and thyroids and deep learning extractions are clinically fused, and we will get the binary classification as a benign or a malignant. Here in this methodology, I have used the ultra sonographic images, and after that in a pre-processing before giving to the convex, that is deep learning algorithm. I have pre-processed my images by resizing, then normalization, and the noise is reduced by some filtering method. And to enhance the quality of that image, the pre-processing technique is takes place. Then to extract the feature, here the advanced CNN algorithm, that is convexness feature extraction, is used. Now thyroid is basically thyroid, that is nothing but a thyroid imaging radio and data system. This is basically used by radiologists to manually calculate what is the score of that ultrasonic USG images for that thyroid, whether that cyst is belong to benign or malignant. Now here five features are there in thyroid. This is basically this method is standardized by American College of Radiologists, and this is used all over the world. Here five features are there. One is a composition, echogenicity, shape, margin, and echogenic foci. Now here for each feature, some points are fixed, so some points are given, and as per that images, the radiologist expert assign the points, so that if the points are 0 to 2, then that cyst is benign. And like that, in next slide I will show you how that points are segregated. Now here for my research I'm using the real time database collected from
Excuse me.
Solapur Diagnostic Center. Yes, hello.
This is just a gentle reminder that 1 minute is left for your presentation, so please conclude.
Okay, I'm sorry. Okay, so database is collected from Solapur Diagnosis System. So this is a huge database over the range of 10 to 70 years of patient. Before pre-processing, the pipeline is resizing, then normalization, noise reduction, and contrast enhancement. Now here for this thyroid, these thyroids are segregated into five features: composition, echogenicity, shape, margin, and echogenic foci. So radiologists give that point to each image so that they can segregate the image into TR1 to TR5. And if the points are in between 0 to 6, then there will be 0 to 2, that cyst is belong to benign. And if the points are up to 6, the moderately suspicious. And but if the points are greater than 7, then radiologist suggests for a biopsy. This is the structure for my convexness. Here this structure is divided into again three sections: image acquisition, pre-processing, then feature extraction, and then binary classification. Here this clinically guided feature. Now here the thyroid score competitions are clinically observed with this five features. Now here the main novelty of my research is, here I have integrated the thyroid score with deep learning feature to find out the accurate result. This is the algorithm. With that algorithm is divided into 5 steps. And my research is find out trained with the use of Adam optimizer with 32 batch size, and learning rate is 0.001, and training time is 8.5 hour to 9 hours, and I have used a 5-fold cross validation. Here I got the 96.23% test accuracy for this 6017 images. Out of that for true test image, I have used 276 true positive and 286 true negative, and the malignant and benign results are like this. Sensitivity and specificity are there. So I have also okay the if you perform with the only with the help of deep learning, then the accuracy is 92.4%. If you perform with the help of only the thyroid system, the accuracy is 88.7. If you incorporate both and if you combine both this system, then my proposed fusion gives a 96.23% accuracy. I have also taken the benchmarking with the help with other system like ResNet, VGG16, MobileNet, and my proposed model gives a better accuracy than other. Okay. So conclusion, a hybrid framework combining a thyroid clinical assessment with a convex deep learning model for a thyroid nodal classification is presented. The proposed approach achieved 96.23% accuracy. Combining the structural clinical knowledge with automated feature learning improves both performance and the interpretability, supporting reliable clinical decision making. This study is limited. The major drawback is that this study is limited to a single center database. My future scope will be I will use the multi-center data set, and thank you. This is from my side.
Thank you. My question is that what is the role of D3 and D4 in thyroid?
T3 and T4.
T3 and T4. Yes.
Okay, this T3 and T4, these two hormones controls the metabolism of the body. It controls the temperature. It controls the brain. It controls the nervous system. It controls the respiratory system. Depending upon these two features, two hormones, the hypothyroid and hyperthyroid. These two types of thyroids comes. So in short, these two hormones controls the overall body.
What is ultrasound imaging? Ultrasound images.
Okay, this is the non-invasive images where the ultrasound what?
It's basically why you are using ultrasound images. Means for doing non-invasive.
Yes. There are different techniques are available for to diagnose the thyroid. Like blood test is there, which is an invasive technique. CT scan is there. CT scan is there. MRI is there. These techniques, biopsy is there. These are the invasive technique, and non-invasive only thermal imaging and ultrasound imaging. These two imagings are non-invasive, and radiation-free techniques are there. These two are radiation-free techniques.
What is piezoelectric effect in ultrasound images? Piezoelectric effect.
Piezoelectric effect. It penetrates that rays to that cyst, so that you can come to know that radiologist can come to know the cyst. That radiologist can come to, categorize that 5 features: composition, then margin, shape. If that rays are penetrate, then that cyst, if you find the composition, no, that composition is cystic or a solid structure.
Okay.
So to find out the
is these ultrasound images are in used somewhere?
Yes.
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 Nowadays it is used.
Yes.
Okay. Instead of blood, you are taking the ultrasound images, right?
Yes.
Thank you.
Okay. Thank you.
Thank you for your presentation, Nubin.
Okay.
Up next, we have Nida Saifi presenting the paper titled ClinGen, Retrieval Augmented Generative AI Framework for Clinical Node Generation and Symptom Analysis. Nida, you may start your presentation.
Okay.
Today you may start.
Thank you, everyone. I'm Nida Saki, and I'm handling content from ABS Engineering College. And my topic is CleanGen, a retrieval augmented generative AI framework for clinical node generation and symptom analysis. And I have done it is in the under the supervision of Dr. Anil Kumar Dubey. And so basically, the problem statement is clinical documentation is critical part of healthcare, and it is a time-consuming and repetitive task for healthcare professionals. So manual creation of SOAP note increases clinician workloads and contributes to burnout. And we can see manual documentation can lead to inconsistent inefficiencies and less time to direct patient healthcare. So, and recent advance in generative AI to natural language processing and RAG, they offers new opportunities. So they can produce more as we can see that existing generative AI, it may produce hallucinated or clinically inaccurate notes because it can be made upon on the outdated information. So lack of medical context and evidence reduce on the reliability of AI generated documentation. So there is a need for AI assisted framework that can generate accurate and structured clinical notes based on the sort format, which is subjective, objective assessment and plan. So my research objective is to develop an AI assisted framework for automatic SOAP node generation. So I have utilized RAG, which is retrieval augmented generation, to improve contextual accuracy. So whenever it converts doctor-patient conversation into structured clinical documentation. So it also reduces hallucination by grounding its responses in retrieval medical knowledge, basically retrieval augmented generation. It retrieves or fetch the information from the provided context. So the provided response should be context aware. So it improves documentation efficiency and it also supports healthcare professionals so that they should not they can give more time to their to one-to-one doctor and patient care so that their workload can be reduced and the healthcare professional burnout should be less. The methodology to basically this is my methodology which is to provide an input data, which is the input data will be doctor patient conversation or symptom description, which as provided as unstructured data. Then the pre-processing of data will be done, which is text cleaning, tokenization, stop word removal, embedding generation using NLP techniques. So the knowledge retrieval are there. So the RAG, which is retrieval augmented generation, it retrieves relevant clinical information from the provided text or the medical knowledge so that it should provide a contextual evidence. So there is a no generation. Okay, as I have told you earlier, so the generative AI model produce structured clinical notes in SOAP format, which is subjective objective assessment plan. So it give you the review in 4 terms, which is it will provide the subject, then object, then assessment, what can be the plan, what could be the remedies for it, and the symptom analysis. So we have used machine learning models such as random forest, SVM, and KNN. Yeah. Support vector mechanism and K nearest neighbor, which to analyze symptoms and rank possible condition. So to support documentation, it is not like that. It is a supporting elements in it. The diagnosis must be provided by at the end of the day should be from the healthcare professional, but it just to make sure it is the provided text is in the documented form, which is in SOAP notes and in a structured way. A clinical validation, human in the loop, which is as it doesn't matter if the data is if the notes is made by the AI or the human, it should be reviewed from the healthcare professional or the clinician. So it should be free from the hallucination, and before it should be given into a decision of clinical notes so that it can reduce hallucination and improve reliability. Okay, the deployment this framework is implemented as a Python application which enable real-time clinical note generation as soon as you provided the text or an unstructured text or a doctor-patient conversation. It should convert into a desired format. So this is basically my result and findings. So as we can see, the random forest achieved the highest performance. So this is my model, and the RAG improved contextual understanding of clinical information. So structure soap reduce documentation efforts, so it will reduce the clinician burnout and human in the loop, as we have already told that it will for the validation of minimize hallucination and enhance reliability. So the model is random forest, SVM and KNN. As we can see, the random forest it has achieved the highest performance based on all of it. So, okay, the conclusion on future work is the proposed framework. This is a retrieval augmented generative AI framework with short note generation. So, it successfully convert unstructured clinical notes into structured soap documentation. Then the RAG enhance factual consistency and reduce hallucination because it provides a context aware text. So, it should not be the response should not be different from the provided context. The framework this has the potential to improve clinical workflow and documentation quality, which is and if we are talking about the future work, what can we do in this field so that we can integrate it with electronic health records. So it may for the future for the enhancement of this model so that AI system framework so that it works great with EHR2 and support for multi-model images like it is not supported for images and lab remote so that for the enhancement we can make it for multi-modal medical data like images, lab reports, etc. And advanced NLP if we are talking about so it should support the advanced NLP and large medical knowledge bases, real-time conversation, clinical assistant, and we're talking about explainable AI, which is an enhanced version, and in XAI, and for the and taking continuous clinician feedback, it can make more precise and accurate result, so that we can use we can provide more training to our data set so that it should provide more accurate and precise results. That's it.
Hello.
Yes, sir.
Okay. My question is, what is RAG?
Okay, so retrieval augmented generation is basically it retrieves from the provided the information we provide it fetches from it and provided the context aware response so that the response should not be different from the provided.
What is the role of SOAP?
Yes, so soap node generation is and in hospital it is also that there is a soap node generation, the subjective, objective assessment and plan. So it provides a better enhancement of clinical node generation uh, in a structured manner.
What is large language model?
The large language model it helps computer to it is a trained it helps computer to understand the provided it helps computer to understand the provided context given by in human language to read and interpret in so that they can talk like human. They can respond like human.
Okay, Ninda. Thank you.
Thank you, sir.
Thank you, Neeta, for your presentation. Now we have Pratima presenting the paper titled Development of a Stochastic Model and its Application in Engineering.
Am I audible to everyone?
Yes, you're
Hello.
audible.
Good afternoon to everyone. Can you see my screen?
No, it's not visible.
It's not. 1 second. Is it visible now?
Yes.
Is it visible now?
Yes, Pratima,
Hello.
it's visible.
Yes, so good afternoon, everyone. My name is Dr. Pratima Rai, and I am from MIT University, Dubai. So my research title is Development of a Stochastic Model and its Application in Engineering. In engineering, if we think many things are uncertain, right, such as material quality and machine failure, environmental conditions, and due to promotion, due to customer demand, so many things are uncertain. So this study develops a model, a such type of mathematical framework which can deal with uncertainty, which can deal with failure, which can improve the reliability of the system or unit. So, if we talk about traditional
Dr.
engineering,
Pratima,
yes.
please make it full screen, F5.
1 second. Just a minute. Is it now full screen? No?
No, your entire screen is visible. Can you please like share your presentation in presentation mode? Are you on Windows?
1 second. Yeah, I'm trying. I'm doing this entire screen. Is it now full screen?
Your entire screen
Just
is
press
visible.
F5.
Can you please
Press F5.
put it? Yeah.
Hello.
Press F5. On keyboard, press F5.
Press what?
F5. F5.
The function key.
1 second.
Otherwise, you
Just
can go.
Just a minute. I'm sharing again. 1 second. Entire, yeah, I'm sharing my entire screen.
Dr. Pratima, that is not the issue. It would be better if your presentation was in presentation mode. Session Chair, is that necessary or can we continue like this because this is taking
Continue.
quite a lot of
Continue.
time.
Continue.
Thank you.
Okay, thank you so much. Thank you. So if we talk about the traditional engineering, in traditional engineering models, they assume like everything is fixed and everything is predictable. But in reality, many factors change. Many factors change randomly. So it can be due to customer demand, it can be due to weather conditions, or it can be due to promotions or customers' demands and desires and needs. So that's why I selected this stochastic model, because it deals with the uncertainty. It deals to improve the reliability of the product or system. So the main objectives of this research are: first, to develop a stochastic model to create a mathematical framework which can deal with the uncertainty. Next, to improve the product reliability. And in the last, to compare the stochastic model, to compare the mathematical framework with the deterministic model. So this model shows the future value depends on the current value plus random error plus random fluctuation. So here xt plus 1, it denotes, it represents the future value of the system or product, and xt, it is the present value, and epsilon t, it is the random error or random fluctuations. Methodologies which are used in this research papers, which are maximum likelihood estimation, which is used to estimate the parameters of the data set, and Sobol indices, which is used to identify the important uncertain factors, and validation to check the model accuracy, and the Sobol indices identify again important uncertain factors, random factors. Monte Carlo simulation, which is the most important methodology, it is used, it is based on the repeated testing. It repeats the system, it repeats the simulations 100,000 times, and to in random situations, in random variables, input will be random variables, and then we find different outputs for the system. So by this way, we can predict the system behavior, we can find out the failurity rate, we can check the reliability, how many times a system or unit is going to fail. So we can find the failure rate. So Bayesian inference also, Bayesian inference, it updates the probability by using the evidences, by using the historical data. So these all are the methodology overview. So Markov chains here, Markov chain says Pxn plus 1 model is this, Pxn plus 1 equals to j, xn I and Pij. So here this xn equals to I, this is representing the present value. And here xn plus j is the future value and I is the present value. And probability Pij, it denotes the probability from state I to state j. So Markov chain basically it works with the transition matrix and steady state. So transition matrix, it is used to increase the reliability because it allow us to predict the system behavior, and also it identify the failure patterns. So in this formula here, as I said that Pij, it defines the probability from states I to state j. So in transition matrix, we find different states, like whether machine is in working state, or it is in repairable state, or it is in a completely failed state, or partially failed state. So it defines the different states, different possible probability. Whether if suppose machine is the probability of failure rate is 90%, then maybe there are 10% chances then machine can work properly. So like this it defines the whole table. And steady state, it works with the long run stable conditions where probability no longer change. Next is the Poisson, it works with the random process. So what it does, Poisson process provides a mathematical framework for stochastic modeling by capturing random events occurring over time. And again, here exponential distribution also we use. So exponential distribution, it defines the time intervals. So time intervals means here this is the stochastic model, and my main motive is to improve the reliability of the system. So in here in reliability, the time interval is time between machine failure. To find out the time between machine failure, and how does it work, it identify the random events, then estimate the probability, and then estimate the next time until the event, next time we get the event, and then it builds the stochastic model, it builds the mathematical framework. So next we have Monte Carlo simulation. It is most important methodology which I used in my research. So Monte Carlo simulation, it is a method that uses repeated random sampling to study uncertain systems. So it answers what will happen if randomness affects the system many times. So what how it does, how it works, instead of using one fixed value, it runs the system or unit in different many times, 1,000 times, 5,000 times, using random inputs. And like this we find the different outputs. So here ex represents expected outcome, and xi, it is the result from each simulation, and n is the number of simulation. So this model is needed because it defines uncertain variables, and then it can be machine reliability, failure rate, repair time, and then assign the probability. So here possible probability distributions can be Poisson, exponential, and normal distribution, because these distribution work with the randomness. And then it run repeated simulations. So this model simulated many times, 1,000, 5,000, and 10,000 times, and each run gives different outcome due to the randomness. So now in the last, we can estimate the expected system behavior, and then we can managers, they can decide the maintenance team, they can reschedule the maintenance so that we can reduce the cost, and we can by this way we can improve the reliability. So this is the all are the steps which we follow in Monte Carlo simulation. So next we have random walk. So random walk also, it provides a foundation for stochastic modeling by representing uncertainties. So where variance, it assess the uncertainties, it assess the risk in the unit or system. And expected value, ESN, it represents the expected value, estimates long-term system behavior. So these all are the methodologies which I used in my research. And then graphs and diagrams, I explained all these methodologies through the graphs and diagrams. Markov transition diagram, Poisson distribution graph, exponential, and random walk, and histogram.
Pratima, can you hear
So
me?
yeah, I can.
Sorry to disturb you. You have 2 minutes left for your presentation, so please be mindful of the time.
Okay. So I'll just going to finish it, and just findings and the limitations I will just explain. Okay, so these all are the graph, Markov diagrams, and then Markov transition, which I just explained in my research methodology: Poisson, exponential, random walk, Monte Carlo simulation. And applications, we can apply this mathematical framework in civil engineering to find out the check the traffic flood prediction, mechanical, which I am applying here in reliability. We can apply this mathematical stochastic model to check the motor pump reliability of the motor pump which we use in villas. So in my next extended research will be, I will apply this mathematical framework in the mechanical field, where I'm going to apply this model to check the reliability of the motor pump which we use in villas. So that we can find out the failure rate and uncertainty, and we can reschedule the maintenance team or timely before the pump is going to fail. So this is my future scope of this research. And advantages, it improves the reliability and it handles the uncertainty. Also it is the realistic model, and we can integrate this stochastic model with the AI, artificial intelligence, to bring the more accuracy in the predictions and to bring the more reliability in the data. So limitations are like, it is computational complexity, like if and it is totally based on the data input, right? If data is more noisy and data is more extensive, then it will be more expensive. If we run, suppose, Monte Carlo simulation 100 times, 1,000 times, 5,000 times, then it will be a quite expensive and time taking as well. So findings, I can say that the proposed model successfully captures uncertainty present in engineering systems, and also it provides more realistic predictions than conventional deterministic models. And another thing is, second, reliability prediction improved. So the proposed model estimates the system reliability using repeated Monte Carlo simulations. Bayesian inference, it improves the parameter estimation by combining historical data with the new observations. And the stochastic optimization, it approaches generates more reliable engineering decisions than deterministic optimization. So the novelty of this work lies in integrating Monte Carlo simulation, maximum likelihood estimation, and Sobol indices analysis, stochastic optimization into a unified engineering reliability framework. So this integrated approach provides a comprehensive methodology for analyzing engineering systems under uncertainty. So the model, it can be applied again in mechanical components, pumps, motors, manufacturing systems, industrial machines, power systems, and transportation route systems. Yeah, so I explained my whole research and scope also, where I'm going to apply this mathematical framework in future.
Okay,
Thank you so
Dr.
much.
Pratima.
Thank you.
May I know?
May I stop sharing my screen?
Yes. May I know
Thank
what
you.
is the use of Poisson process in your research?
Poisson process, it works with the randomness. So it deals with the, as stochastic model, it deals to with the uncertainty, and it is used to improve the reliability of the system or the product. So Poisson process, it collects the randomness. It works basically with the randomness to find the uncertainty and failure rate of the system. So it helps to managers to take the decisions timely, so before system failure. And exponential also we are using here, which find out interval time. And as we are talking about reliability, so in reliability, interval time will be event rate. Next event rate will be machine, when next time machine is going to fail.
Okay.
If we suppose run any system, so what is the next time after 1 hour or 100, suppose after 1 hour or 30 minutes, if suppose we are giving this much temperature, then when, which time machine is going to fail, so exact data we are going to record.
Okay, what is the use of Monte Carlo process in your research?
Monte Carlo simulation, it basically, it is used, it is based on the repeated testing. So this stochastic model, it is here I am using this stochastic model to improve the reliability and to check the uncertainty. In Monte Carlo simulation, the system is going to run 100 times, 1000 times in different and random variables, by using random variables, and we are going to get different outputs. So on the basis of those results, we can take the decisions, we can predict the system behavior, and we can do the better prediction.
Okay, Dr. Pratima, thank you.
Thank you so much. Thank you. May I leave?
Yes.
You can
Thank you. Thank you so much.
Thank you for your presentation, Dr. Pratima.
Thanks so much.
Up next, we have Dev Shah presenting the paper titled Drift Detector, a personal based and approach to authorship consistency verification in academic writing.
Good afternoon, everyone. Am I visible?
Yeah.
So, just a minute.
You may start your
Is my
presentation,
screen
Dev.
visible? Yeah. Good afternoon, everyone. I'm Dev Shah, and I'm presenting my work with Dr. Suchintan. Our paper introduces drift detector, a personal based approach for the authorship consistency verification in mainly academic writing. So, the main problem statement that we are trying to address here sits in a gap between two existing tool categories, which are traditional plagiarism detectors and AI detectors. Plagiarism detector compares a submission against the external corpus, and they might fail when no source documents exist, which is the case when a student writes their own essay and uses AI to polish the pose. AI text editors target fully generated content and break down under light paraphrasing. Neither was designed for the scenario. So the research question is, can statistic drift from a student's own authenticated writing history serve as an orthogonal detection signal? Our idea was simple. Instead of comparing a submission against the outside dataset, Why not compare it against the student's own past writing example samples? Everyone has a writing fingerprint. How long the sentences tend to run, how complex the grammar usually is, what type of vocabulary they try to use and try to fit into the words that they're using. And if a new submission suddenly doesn't match the past history of the student, that's a signal worth looking for in case there might be a authorship issue. We collect authenticated prior writing to build a personal baseline B. When a new submission S arrives, equation 1 computes a stylistic comparison between them, producing a drift score that maps to one of the three verdicts. Low meaning that the new submission is likely written by the same author. Moderate meaning that AI might have been used to polish or in, add on the writing style. And high likely meaning that the author is different from the previous submission one. There were no existing dataset for this. So we built one using 121 graduate undergraduate papers and split them into thousands of sections, which were mostly from 40 words, depending to 300 words. We had two different AI models, GPT and Claude, lightly edit the copies of them, which both were given the same prompt and the same source text. So the output that we got was quite compared. That gave us over 22,000 plus pairs to work with. Some were generated by AI and some genuinely from the authors and some contented different authors. On the technical side, we combined two approaches. First was four measurements, being the sentence rhythm, like does the student mix short and long sentences the way we usually do. Second being the synectic depth, are the sentences as grammatically complex as usual? Third was lexical diversity. Is the vocabulary range consistent with the student's normal writing from the past? And fourth being the punctuation density. Are there any un, uh, uneventful or the new type of punctuation methods that the student is normally following? Each feature is expressed in a Z score. How many standard deviation it deviates from the student's personal baseline. And the second is a neural network that learns how stylistically far apart two pieces of writing are. The neural component uses a CMS network. Both texts are embedded by the pre-trained all-mini LM sentence transformer, compressed through a shared encoder of 128 dimensional style fingerprints and elucidance distance. Training uses contrastive loss equation to pulling same author pairs uh, closer and pushing the different author pairs apart. And for the weight combination method, we combined both the previous features, and the equation 3 combines both signals, taking 35% from the neural and 65% from the statistical one. The neural component is effective at separating different authors, but usually gets confused when two texts discuss the same topic. AI edited text shares content with its original. So embeddings see them as a similar the even when the style is changed. The statistical feature only measures how someone writes, not what the writing is about. So that compensates the average. Here's something I would actually like to walk you through. When we first validated the model, our accuracy score came back at 0.185, which is worse than a random guessing. Our first reaction was that something in the code was broken, but instead of assuming anything, we decided to break down the details category wise. And that's when it got interesting. The AI edited pair was scoring lower than genuine same author pairs, completely backward from what we had expected it to be. It turned out that the model wasn't broken at all. It was working correctly in a direction we had not anticipated. When AI edits a pair of writing, it keeps the ideas and the topic, meaning everything same, even though the style has changed. Meanwhile, two genuine essays by the same student, if they are about completely different topics, can look further apart than they are. After the fix at the essay level, we tested 120 cases from 10 different authors and the cross-author detection accuracy was about 76.7%. And that was our main objective. Overall accuracy was about 69.2%, and same author accuracy was 50%, which was not the expected one from the start. And we got to know that it reflects that inherent difficulty of separating natural topics from a same writer can vary from a genuine drift. One more thing was quite interesting. We used two different AI models to generate our AI edited examples, GPT and Claude. We initially expected them to behave more or less same, but at the end they didn't behave the way we expected. Like GPT's edit were very subtle that our system was still able to recognize the author 70% of the times in the test cases. However, on the other hand, Claude edits were more aggressively different in a stylistic way that the model was not able to catch it on most of the cases. Like 80% of the times, it was not able to catch the Claude's pair. Even though we use the same prompt, same source text, everything was same from word to word, but it had very different editing fingerprints. That tells us that there is no single AI writing style. Every model has differently writing style. Any detection system needs to get an account for that. To be upfront, where it stands, we tested this on published academic writing, not verified student submissions. So that's the next real test that we are hoping for. We also trained only on one type of writing, that is like rhetoric, composition, and cross-discipline, not on the STEM, law, and the medicine one. So we don't know how well it is going to stand on that scenario. But yeah, the core idea of comparing the students' new submission against a past work is quite different than the existing traditional plagiarism and the AI detectors. To summarize this, we introduced a personal baseline detection paradigm for over 22,000 plus pairs and achieved a 76.7% cross-author verification across 120 different types of work. For future work, we are looking for verified student submissions, feature augmented CMS architecture, cross-discipline expansion, and head-to-head comparison with the traditional plagiarism and AI detector tools. Thank you so much for this opportunity, and I would like to take any questions from now on. Can I stop the screen sharing?
Yes, yes, yes. You can stop the screen share. Okay. Dev, what is neural network?
Neural network is basically creating the data set where the machine learning model would train on a data set, exact existing data set, and it detects on what scenario how the system is working. So it helps us to predict that how it is going to differ in the future.
Okay, what is weighted combination scoring?
Sorry, sir?
Weighted combination scoring.
So in that one, the four statistic features that we took, the weight of that and the neural network was completely differentiated. Like initially, we decided it to be 50-50%, but during that version, we got very different scores and quite fascinating results. So we got to know that the neural network had more weightage and was not able to identify the writings on the basis of the stylistic change. It was looking for the same meaning or the same type of words and the meaning basically of the paragraph level. So in that case, the stylistic features like the punctuation differentiation, the grammatical depth, and other features were quite useful. So we decided to add more weightage to that and take the less weightage from the neural network that was trained on.
What is essay level evaluation?
On the essay level, the main objective is that the meaning of the authenticated pair, that is my writing from my own hands, and the edited version of the same one, are they looking the same? Like, are there any differentiating factors apart from the meaning, apart from the syntax?
Okay, thank you, Dev.
Thank you.
Thank you, Dave, for your presentation. Now we have David Elluvathangal presenting the paper titled FIR Meet Smart Legal Assistant for Automated FIR Generation.
Good afternoon, everyone. Am I visible? Hello.
Yes, you're visible and audible.
So, good afternoon, everyone. This is my presentation. FIR made a smart legal assistant for accurate FIR filing, and my team members were David, me, Jia, Ruchir, Priya, and Sana ma'am. So for this presentation, we will cover these topics: the problem statement of the topic, objective, scope, literature review, proposed solution, system architecture, how the dataset was created, the model training, how it was done, the evaluation metrics of the model, implementation, and the references. So coming to the problem statement, the uh, the FIR document is one of the first and the most critical steps in the crime justice system. Uh, it currently it is time consuming and a manual process, and in which it uses the colonial era rules of the IPC section. The citizens often faces transparency, and the police officers have a lack of legal knowledge on which IPC section to be implemented wherever applicable. Also, from July 1st, 2024, the Indian judicial system officially shifted from the IPC section to the BNS section, which is the Bharatiya Nyaya Sahita 2023, which contained um, which contained 357 BNS sections of the new generation. For this purpose, we have created this FIRMate. FIRMate is an AI-powered legal assistant that helps in streamlining the entire process, right from the citizen to the police officers. It has an inbuilt bot model that helps in predicting the BNS sessions according to the descriptions given by the citizens or taken by the police officers. Multilingual support has been given via text, voice, and chatbot interface, so that it can be accessible both by the literate and the illiterate people. This helps in digitalizing the FIR and making analysis on the FIR documents, so that any kind of trends or patterns can be discovered easily for the police officers. The scope of the project is to implement the BERT model so that the entire 357 legal sections are being used efficiently. As I said, the multilingual model, a role-based platform both for the citizens and the police officers. The literature review, checking the previous research papers and the conference papers of the other people, we saw that most of the papers that were created were based on the Indian Penal Code, and none of the people had made based on the BNS sections. Even if it was made, it was made on the general legal text, or on the court proceedings, or the terms and conditions of the companies, on the company's legal documents. For this purpose, we created the BNS section. The proposed solution, as we said, the citizens can be able to create a EFIR or the complaints, which will then go to a natural language processing, which will then shorten the description and make and normalize it, so that the BNS sections can be predicted when the EFIR or the complaint has been sent to the police officers. This is done via geofencing, so that the EFIR or the complaint is sent to the nearest police station itself. The police officer then can verify the severity of it, and then convert it into FIR model. And if further verification is needed, the citizen will be called within 3 days. This is the entire process. As I explained before, the citizens can log in and generate the FIR based on text, voice, or the chatbot interference. The language processing happens so that the description given is being normalized so that the BNS section predictor can be more accurate. The police officer receives this FIR or can file new FIR and can generate the BNS section based on the processing that it has been done. And finally, the FIR can be created. This is the how the dataset was created using the published FIRs of the of especially of the Mumbai region, and we initially cleansed it and normalized it using Python scripts and created more data so that the dataset can be large. For model training, we used a BERT model and fine-tuned it for training more than 12,000 plus FIR sample that maps 357 BNS sections. As we know, a single FIR may contain multiple BNS sections. It is not specific to one BNS section or an IPC section. For that purpose, we have made with the architecture of multi-label classification, and we optimized with the Adam weight decay. The evaluation metrics that we got was the Hamming accuracy of 97.34. It predicts how much of the BNS section were correct and was correctly classified. The macro precision is how reliably it is being corrected, and the F1 score tells us how correctly the BNS section is being corrected and how well it is avoiding the wrong BNS sessions. And now coming to the our data set of BNS sessions, this has been scraped from the official website, the training data set, evaluation data set, and this is the screenshot of the implementation, both citizen and the police login. This is the citizen portal where they can fill the EFIR and they can fill it via the text, voice, or the chatbot interference. This is the police system, and where they can select the BNS sections based on the output given by the model. And this is the BNS mapping or the section where the police officers can ask questions on which section is correct, or if any doubt comes, they can talk to them. And this is the references that we used. Thank you.
Okay. Okay, David. What is BERT?
Bidirectional encoder representation for for transformers. It basically reads the text from left to right, trying to understand the context and then finds the feature.
What is the use of that BERT in your research?
The BERT is used to finding the features and for mapping the the text, like supervised learning model it is, right? So to match the particular description to the BNS sections.
What is the use of Hamming accuracy in your research?
Hamming accuracy, it basically tells like there are 357 accuracies, right? So based on it, it correctly predict the how the individual BNS sections is correct among the 357 BNS possible sections. So the possibility of that value is really high because even a BNS section that is not that is a correct option. So its percentage will automatically increase.
Okay, David. Thank you.
Thank you, sir.
Thank you for your presentation, David. Next, we have Amita Jaju presenting their paper titled Intelligent Career Guidance Framework, Personalized Career Recommendation Using Machine Learning with Decision Support.
Good morning, everyone. Am I audible?
Yes, you're audible.
Actually, Amita ma'am is busy with her duty work obligations. So, me, Pratik Shingolkar, being the co-author, I'm here to represent the paper today. Is that okay?
Yes, it's okay. You may please start your
Okay,
presentation.
fine. Thank you. So let me start. Let me share my screen. Is my screen visible?
Yes, it's visible.
Okay, thank you. So good afternoon, everyone. I'm Pratik Shingolkar, Department of Information Technology from DY Patil College of Engineering, Pune. Actually, our paper ID is 2030, and our paper title is Intelligent Career Guidance Framework, Personalized Career Recommendation Using Machine Learning with Decision Support. So let me introduce you to our problem statement. It is mostly seen that students face difficulties across selecting career options today because there are wide range of opportunities available today. And also the traditional career counseling, they lack personalization. Even they are unaware of the opportunities, the recent market trends, the socio-economic and background of students, and various other factors. Due to this, career-related information gathering and implementing it becomes very difficult for students. Also, the information is spread across various clustered across multiple platforms and difficult to access. So the existing career systems do not provide such support for the career planning. Therefore, we felt a need for some intelligent career system which uses the artificial intelligence, as AI has been the boom and the key feature of this particular decade. So what we came up is that a framework, but before that, we need to peek into the existing work and research gap that was seen there. So first of all, let we studied some research papers and which were related to our industry, and they came across that there were some predictive flaws or research gap in that. For example, some were black box models with no explainability, no transparency, limited applicability for students, limited data set and scalability and framework. Some just proposed a framework but did not apply it. So actually, we came up with that idea and we tried to implement it, combining various features and proposed a framework. So the solution which we proposed was that Intelligent Career Guidance Framework (ICT). It is an AI-driven support system which provides personalized guidance based on their factors like academic performance, skills, interest, aptitude, backgrounds. And for this, we employed a random forest model. We used the machine learning model called random forest to predict the top three most suitable career domains. The modules which it included were profile analysis, careers prediction, top recommendation. Also, along with that, we came for scholarship mapping, roadmap generation, and chat assistance. Now, let me introduce you the actual architecture of our project. So, as we can see that the client layer, application layer, authentication layer, data layer, these are all what we implemented. But what actually matters is that the work. So, if we go with the workflow, we can see user input, which is collected there. Then the pre-processing happens on the user data, and then our model predicts the best possible career option for him, and the result is generated. And also continuous feedback is there for improvement. So this is how the actually workflow looks like. Let me tell you about the dataset. What we did, uh, what we used was it consisted of standard 500 student records. Input features were used around 40. So, and the target variable was one, which was the career domain. 15 career classes were made in which the careers were divided, and the educational levels were all among the 10, 12 graduation and post graduation, considering economic backgrounds and all catering students from all possible backgrounds. So rule guided mapping was used, in which we had made 500 standard records. So this was all about our data set. The methodology what was used was a three-tier guidance system in which we used data pre-processing was done for the first step. Second was training the random forest classifier. The third was implement extracting the result, and then was the last step was tuning the model. So this was the overall methodology which we used. So this was the basic working of that algorithm, how it used. So that random forest was used, which we use on the decision trees, and this was the logic of it, which it uses. Basically, it works on the concept of bagging. So it is how that is displayed. But most importantly, the thing is the result, the accuracy and the precision values which it offered. So this was the performance which it gave. It achieved 93.48% accuracy, top for the top 1% career which it predicted, 95.41% for the top 3 accuracy. And what we did was cross five-fold cross validation approach. So in order to ensure that there is no such cluster which remains untested, and the OOB score of 92%, and then the F1 score of 93.49%. So as you can see, there were a lot of clusters, including agriculture, arts, business, data science, education, marketing, and all which were divided as per the clusters. And this is the confusion matrix and accuracy matrix. So this gives an overall idea of that the score and the percentage values which I mentioned earlier. But the more important thing is confusion matrix, which shows us that the readily tested models provided very good accuracy on this particular thing. So these are the key features what I wanted to sum up, that we had introduced the framework such that it gathers all particular career aspects into one unified single platform. Student profile analysis, it was web-based interactive framework, and confidence scores, which is the feature importance feature of the random forest, and AI chatbot support. Basically, we integrated generative AI into it, and the roadmap generation with various scholarship assistance. So these are some future scope what we are planning to do it. We are we will try to implement the most accurate results using SHAP for the explainable AI, as the explainable AI currently consists of only the feature importance scores. And we also look for real-time market and job analysis, which we will be used for most particular the trends. A multilingual support for various other catering all the students from different regions. So these are what some of the feature scopes that our application looks like. And finally, coming to the conclusion, I want to say that I think we have catered a lot of students from different economic backgrounds, overcoming the limitations of the traditional career counseling methods, and hence we try to implement this as a single unified platform. So this was what we are proposing as the framework. We believe has the ability to make career related choices a significant decision and transformation in many students' life. So this was all from my side. So now I'm expecting some questions from you.
Okay, Pratik. Tell me about the random forest algorithm.
Actually, random forest algorithm is a machine learning algorithm which uses the concept of bagging. It means that the random forest model has various decision trees in it, which are trained on some particular subset of the data. So each tree predicts its own output, and that particular outputs are combined by using the voting mechanism. So it gives an overall picture of how the what the prediction looks like, and it gives the total result as in the form of the output.
Okay. What is the difference between accuracy and precision?
Accuracy mainly refers to the how accurate means how close the value is, the predicted value is from the actual value. For example, if the actual value is 100 and the predicted value is 99, so it has a very good accuracy. But precision refers to something how close to the actual value we can get. For example, if my value is 99.999, it is more precise than 99. So this is what basic difference between accuracy and precision stands like.
Okay, thank you, Pratik.
Thank you so much, sir. Thank you, everyone.
Session Chair, do you have any questions? Okay, I think there are no questions. Thank you for your presentation, Pratik. Now we'll be moving to the next presentation. Our next presenter is Nitesh Pradhan, who will be presenting their paper titled Waste Classification Using Convenext Small with Encoder-Decoder Architecture and Attention Mechanisms.
Uh, uh, Good afternoon, ma'am. Actually, I'm the co-author of this research. Sir is actually in some work. Can I present the screen?
Yes, you must start your presentation.
Okay. Is it visible?
Yes.
So good morning, sir. Myself, Uday Sharma. I am the co-author of this research entitled Base Classification Using Convex Mall with Encoder, Decoder, and Attention Mechanism. So this will be our agenda of this presentation. So basically, our problem statement is that currently manual-based segregation is very slow, inconsistent, and error-prone at the scale. So the goal of this project is to automate the process using deep learning-based binary image classifier using pre-trained model, specifically for convex mall. So basically, we are having a data set in which we are having two classes, biodegradable and non-biodegradable. And there's a this data set is heavily imbalanced in the ratio 10:1. That is actually biodegradable class is 10 times more as compared to non-biodegradable class in this data set. And we are taking binary classification. We are taking binary classification first because it actually holds the real world relevance, as wastes are divided in these two categories majorly. And it also requires less labeled data per class. And it also provides a deployable baseline. As you can see from this slide, this is a distribution of our current data set. It actually has 15,400 total training images consisting of two classes. The total training set is 11,694 images. Rest 2,506 images are of validation split and 1,200 images are for test set. As you can see from this bar chart that by, the biodegradable images are in total 12,698 and non-biodegradable images are just 1,466. So we need to uniform this distribution first of all. So first task we did is data augmentation, and in that we applied some random flipping, random rotation, random zooming, and random contrasting. Then we applied data pre-processing, in which we first cleaned all the images and resaved them using Pillow and OS libraries. Then we normalize the input images using preprocess input, that is made the mean 0 and standard deviation 1. Then we applied dot shuffle 1,000, that is we maintained a buffer of 1,000 elements in which we selected next element randomly so that our model doesn't learn order-based patterns. Then we applied prefetch auto tune so that while GPU is training on current batch, CPU keeps our next batch ready. As you can see from this slide, actually, in this project, we carried out three cases. We carried out this our project in three cases. First of all, we took only convex small model. This is the architecture of convex small. Second one is we integrated convex small model with encoder and decoder architecture as well. So here, approximately 4 layers of encoder and 4 layers of decoder are added in this architecture. And in next case, we integrated attention mechanism as well in the case two. Here, 2 layers of attention mechanism are added. So actually, in this project, we apply transfer learning. That is earlier we kept our model. We only took convolution base of the model without a we froze. Actually, earlier layers were completely frozen, but now last 20% layers are kept unfreeze. That is because last 20% layers are actually task-specific features, which would be used to filter out the output images at last. These are our training callbacks and hyperparameters, which we use during the model compilation. First one is early stopping, and second one is reduce learning rate on plateau. Our evaluation metrics used are currently accuracy, precision, recall, PRAUC curve, F1 score, and confusion metrics. So these are our results of all three cases. First one is convex small, second convex small plus encoder decoder, third is convex small plus encoder decoder plus attention. From this slide, we can see that the best results we are getting is from case 2 only, followed by case 1 results are better, and at last the case 3 results are worse as compared to case 1 and case 2. So we can see from here that applying attention mechanism lead to the worsen results as compared to the both the above cases, case 1 and case 2. Its reason we would be seeing in the later slides. These are our test set results. Training validation, test accuracy, and train well test loss. This is our confusion matrix and error analysis. From here, we can see that in case 2, we are getting higher precision and higher F1 score as compared to case 1 and case 3. Case 3's F1 score is more worse than case 1 and case 2. Actually, case 2 is far better than all these. Now, the main reason that on adding attention mechanism to encoder decoder architecture, there is decline in performance is that actually on integrating encoder decoder to the on next small, it actually falls skip connections. Skip connections are a type of shortcut connections which actually transfer all the original edges patterns of our original image to the decoder side, so that decoder is able to generate the original image from the compressed image. This is called as multi-scale feature fusion. But on applying attention mechanism, it forces the model to look into the specific features only, which many times leads to loss of important information, which leads to increase in false positives. So some of our challenges encountered were class imbalance. As I told earlier that our dataset was heavily imbalanced in the ratio of 10:1. Second was our images were wrongly formatted, which were later corrected using Pillow and OS library. Third one was catastrophic forgetting risk. So catastrophic forgetting risk is basically in fine tuning. Fine tuning uses very less data as compared to training data as compared to training. So it requires very much care. So that's why it's allotted very less learning rate as compared to training stage. And fourth challenge encountered was recall precision trade-off. Conclusion. So basically convex small converts to 99 plus percent val accuracy in both case 1 and case 2, showing that actually applying encoder decoder with convex small proved to be far better than integrating with attention mechanism as well. And its future work could include we can transfer this binary classification to multi-class classification as well. And second, this project can be extended to vision transformers as well. And third, we can deploy it with we can perform edge deployment along with IoT device. Thank you.
Okay. Uday, what is confusion matrix?
So, sir, confusion. Sir, can I stop screen sharing?
Yes, you can stop.
So basically, confusion matrix is a matrix showcasing the trend, showcasing true positive, false positive, true negative, and false negatives. The ratio of it's a complete table showcasing all the ratio of true positive, false positive, and true negatives and false negatives.
Is there any role of true positive, false positive in calculating the accuracy and precision?
Yes, sir. Sir, in precision, true positives and false. The role is mainly of true positive and false positives. The formula of precision is true positives upon true positives plus false positives. So basically, and false positives represents the data which is wrong but classified as correct.
Okay, Uday. Thank you.
Thank you for your presentation. And with that, we've come to the end of technical session 4E. I sincerely thank all the authors for the excellent presentations and valuable research contributions. I also thank all the participants for being a part of this session of the 11th International Conference on Information and Communication Technology for Sustainable Development. I hope you found today's session informative and enriching. On behalf of the entire organizing committee, we extend our heartfelt gratitude for your continued support, not only for the 11th edition, but also for all the previous editions. We look forward to welcoming you again at the 12th ICT4SD conference in 2027. All presenters will receive their digital certificates via email within 2 working days. The conference proceedings are expected to be published within 7 to 8 months. We kindly request your continued cooperation with the organizing team throughout the publication process. I would also like to express my sincere gratitude to our session chair. And as a token of our appreciation, we would like to present this to you, sir. So, do you have any closing remarks for us?
Thank you, madam. Okay.
Sir, would you like to say a few words?
Yes. Good afternoon, everyone. As we come to the end of the session, I express my sincere gratitude to all presenters, participants, and members of the organizing committee for making this session both informative and engaging. Today's session showcased the wide range of innovative research ideas and practical applications in the field of information and communication technology for sustainable development. Quality of the presentation reflected the dedication, hard work, and research excellence of all the authors. I would like to congratulate each presenter for their valuable contribution. Your efforts addressing the world challenges through the research are truly commendable. I also appreciate the active participation of the audience whose thought, questions, and constructive discussion enrich every presentation. Research conference such as ICT4SD play a vital role in promoting the knowledge, sharing, interdisciplinary collaboration, and the exchange of innovative ideas among the researchers, academics, and industry experts. I hope the feedback shared during the session will help the authors further improve their research and inspire future collaboration. I extend my heartfelt thanks to the Global Knowledge Research Foundation, GS Scholastics Ranger, the organizing committee, the technical team, and all the volunteers for their excellent coordination and smooth conduct of this conference. Finally, I congratulate all the authors once again. Wish you continued success in your research journey. Thank you, madam.
Thank you, sir. We really appreciate you taking out your time and being present with us here today. Now I request everyone to please turn on their camera so that we can have a quick snapshot of this session. Okay. Thank you everyone for joining us today. I hope you have a great day.
Thank you, everyone. Thank you, sir.
Thank you, everyone. Thank you, sir.
Thank you.